Section 12.2 is on angles and angle measure. The standard position of an angle on the coordinate plane looks like this. It's the pink angle that I've drawn here. Its initial side is a ray on the positive x-axis, and its terminal side is the array that rotates about the origin. So in this case, it happens to be in quadrant 2. It could be in quadrant 1, 3, or 4. And I've indicated kind of the direction of the angle with this purple arrow right here. If the angle is positive, then the rotation is counterclockwise, as it is in this diagram. If the angle is negative, the rotation is counterclockwise, so it would kind of go down this way. So let's take a look at a couple examples here. This says, draw each angle with the given measure in standard position. So I need a 210 degree angle. So my initial side is going to be here on the positive x-axis. It's going to be going that way. And I need to figure out how far around I need to go. I'll do this in blue. Okay, so up to here would be 90 degrees. Up to here would be another 90 degrees, 180 degrees. But I don't need another 90 degrees because that would put me at 270. So I'm going to do 210 minus 180, which gives me 30 degrees. So that means I need to go about a third of the way through here. So let me go ahead and draw the rest of this. And I'm going to indicate that this right here is a 30 degree angle. So this would be a 210 degree angle, starting here and going around 90 plus another 90 plus another 30 for 210. Negative 45 degree angle is also going to start on the positive x-axis, but since this angle is negative, it's going to be going clockwise, so it's going to go down this way. So from the positive x-axis to the negative y-axis would be 90 degrees, but I only need half of that. Actually, I think I can probably draw this. It would look something like that. And I'm going to go ahead and add my little blue arrow here to indicate that that's the direction I'm going there. And I'll label that 45 degrees. So that would be a negative 45 degree angle. And our last example of this type says we need to draw a 900 degree angle. Okay, so I know that all the way around is 360, so clearly I'm going to be going around more than once. But how many times? Let's do a little math here. So 900 minus 360 gives me 540. So that's once around. I'm still more than 360, so let's subtract 360 again. And that's going to give me 180, which is a half a circle. So a 900 degree angle goes around once, twice, and a half. So 2.5 times around. And because this is a positive 900, I'm going to be going in the counterclockwise direction. So there's my angle. Okay. And I'm going to be going around, starting here. There's once around, twice around, and I'm going to stop right there. That's a halfway around. So my angle actually is going to end up being a straight angle and look like that. But that blue kind of spiral there is important to show you that you've gone around once, twice, and then another 180 degrees to make it all the way around for 900 degrees. Coterminal angles are two or more angles in standard position that have the same terminal side. So for example, in this diagram, 120 degrees and negative 240 degrees are coterminal angles. They both start here on the positive x-axis and they both end up here partway through the second quadrant. But if I go 120 degrees counterclockwise, it's the same thing as going negative 240 degrees clockwise. Also, 480 degrees and negative 600 degrees are also coterminal if you go all the way around again. So if I were to do 360 plus 120, that would give me 480. Or if I were to do 360 plus a negative 240, that would give me a negative 600. So this example says find an angle with a positive measure and an angle with a negative measure that is coterminal with the given angle. So basically the way we're going to do this is we're going to say 210 and I'm going to add 360 to that to give me 570. That would be one angle. And then I'm going to do 210 minus 360, and that gives me a negative 150-degree angle. So those two angles would be coterminal with a 210-degree angle. One is positive, one is negative. So now for negative 120, I'm going to add 360 to that, and that gives me 240. So a 240-degree angle is coterminal with that. Sorry about that. And I'm going to subtract 360, and that gives me negative 480. So a negative 480-degree angle is also coterminal with negative 120 degrees. Radians. This is another way to measure an angle other than degrees, and you're probably familiar with this from your calculator, saying that you can put it into degree mode or radian mode. And in the last section I made a point to tell you that you make sure your calculator's in degree mode when we're solving those trig functions. But a radian is another way to measure this angle. So angle theta here is 1 radian, and it's the angle that you get when the arc out here on the circle is the same length as the radius. So notice that the length of the arc is the same as the length of the radius, and it's the angle that intercepts that arc that is 1 radian in measure. So since the circumference of a circle is 2 pi times the radius, and if the radius is 1, substituting 1 in here, I get that the circumference of the circle is 2 pi. So that means that all the way around the circle is 2 pi radians. So 2 pi radians is the same as 360 degrees. So one thing that's useful to know how to do is to convert degrees to radians and radians to degrees. To do that, to turn degrees into radians, I'm going to take the degree measure and multiply it by pi over 180. Why 180? Because halfway, if all the way around the circle is 2 pi, halfway around the circle is just pi. So pi over 180 is basically a unit multiplier. It's the same thing. So degrees times pi over 180 equals radians, and then do the inverse of that, radians times 180 over pi, will give you degrees. And I'm going to show you when we do some examples, I'm going to show you a little shortcut that I have for remembering how to do that. Okay. Here's a chart from your textbook that shows basically a circle with all of the degrees and radians on there. It's not necessary at this point that you memorize this, but it is good to be familiar with it. So 0 and 2 pi, or 0 and 360 are kind of the starting point here on the x-axis, positive x-axis. And notice that as you go around in the counterclockwise direction, your degrees are getting larger, as we've talked about. Also, too, are your radian measures, and this is radian measure. So 30 degrees is the same as pi over 6, 90 degrees is the same as pi over 2, 180 degrees is the same as pi, and so on. It's a good thing to be familiar with. Okay, and our last couple examples here, not our last example, I'm sorry, a couple examples here tell us to convert each degree measure to radians and each radian measure to degrees. So number one, we have 30 degrees. So I want this to be turned into radian measure. And notice that all of the radian measures have pi in them. So I'm going to need to use the multiplier that has pi on top. So I'm going to do 30 times pi over 180. Oops, forgot my fraction bar there. Okay, and canceling, that becomes a 1, that becomes a 6. So 30 degrees is the same as pi over 6. Okay, negative 50 degrees, multiply that by pi over 180. Okay, nothing cancels here except for my zeros, so that's going to be equal to negative 5 pi over 18. Example number 3 here is 5 pi over 3, and since that's in radian measure, I need to convert it to degrees. Degrees does not have pi, so I have to do something so that I can cancel out that pi. So that means I'm going to do 5 pi over 3, and I'm going to multiply it by the expression that has pi on the bottom, 180 over pi. Because now my pi's will cancel out, because I can't have it pi in degrees. And this is going to turn into 60, so 5 pi over 3 is equal to 300 degrees. And the same thing here for negative, let me move that up a little bit, negative 7 pi over 3 multiply that by 180 over pi. My pi's will cancel. That'll turn into a 60, so that is equal to negative 420 degrees. And the last concept we're going to take a look at in this section is called arc length. And you may remember this from geometry. We did calculate the length of an arc, but in this case, we're going to be using radians. So you'll recall that the arc length is the length of the arc intercepted by a central angle. The way I like to think about this is a central angle is like a slice of pizza. Okay, the arc length is represented by the crust of that slice of pizza, and it's how long that is, not how many degrees it is or how many radians it is, but how many inches or millimeters or feet or whatever that length, the length of that pizza crust. So this formula says the length of an arc, S, is the product of the radius of the circle, R, and the measure of the central angle, theta, in radians. So this is a little simpler than the one that we did in geometry. So the arc length is equal to the radius times the angle in radians. So let's take a look at an example here. So this says find the length of this arc and round to the nearest tenth. So here we have a 100-degree arc, or 100-degree angle, central angle. So that means that this arc, the measure of this arc is 100 degrees, but I need to find its length. And I know that the radius is 4 feet. Okay, and my theta is 100 degrees. That's my angle, but I need to turn that into radians. So I'm going to do 100 times pi over 180. Okay, my zeros will cancel. This becomes a 5. This becomes a 9. So 100 degrees is equal to 5 pi over 9. Now, using my formula, S equals the radius times theta, or 4 feet times 5 pi over 9. And plugging that into your calculator, I get that. So I did 4 times 5 times pi divided by 9. 6.9813. Of course, it's going to be irrational because pi is in there, or approximately, let's round that to 7.0 feet. So that's how you use the formula for arc length. So in this lesson, we took a look at angles and angle measures, how to think about and how to draw angles on the coordinate plane, coterminal angles, learned about radians and how to convert from degrees to radians, and a new way to find the length of an arc.